Is Flack the Planet, the web framework that no one asked for. Foreshadowing. So, all right, what is this? What is Flack? A little bit bigger. Is this a tech demo? Is this an elaborate joke? Is this performance art? I don't know, might be. Is this an exploration into some of the weird and wonderful things that Nix can do? You decide after the end of the presentation. Flack was, at least for me, an experience in learning the Nix C and Rust APIs and doing something with Nix that was very strange and exposed me to a lot of strange problems that, well, I'll be able to talk about them here. So, there we go. History of web frameworks. So from the 1990s to the early to mid 2000s, and even today, it's everywhere, we had CGI, RFC 3875. There's a piece of the RFC. Basically, CGI defined an interface, the common gateway interface, for web servers to interact with applications. So basically how it worked is your web server executed a script, that was passed a bunch of environment variables corresponding to the request. So like, for instance, date can be the script that just takes the current date and shoves it into the out directory. Frequently, this was included in an iframe with some meta refresh stuff that automatically, refreshed basically, like that, and it appears like that. So you can see it's printing the current date. CGI was around for a while. It's still around today. Very old web technology. But it's got some problems, obviously. So maybe certain shell commands are fast, like so we have date here that just dumps the date. And you see that the time on it is pretty fast. It's rounding to 0 seconds, which is pretty good. But if you want to do anything that involves a whole interpreter, so maybe parsing some stuff or evaluating some code, like for instance, I have Nix instantiate -- eval here. And it's printing out the current time. You can see that it's like 0.05 seconds, 0.04 seconds per, a little bit up there, 0.08 per call. And obviously, if you want to do things that use Nix in any sort of persistent way, you don't want to be reloading the interpreter every time you do them. All right, so let's talk about what came afterwards. What do we use these days? Well, obviously fast CGI and reverse proxies. So what's fast CGI? Well, it's pretty simple. So it got kind of more popular once people realized that maybe shoving a script into a directory that your web server execs is maybe not the fastest way to serve web applications. Load your app beforehand and have your app render the result on the fly using a process that's actually persistent. And if my JavaScript works, you guys will see. There we go. So like we have a get /API /now, and that returns the current timestamp, which is updating right there. HTML is frequently rendered and served as static files. I mean, this is basically how every web app works in the modern era. All right, so we had the rise of these web apps, right, where people could write just a bunch of code. They were code gets loaded when your web server starts or when your application process starts. You have like Rails, Django, Rack and Sinatra from the Ruby ecosystem, Flask from Python, and Express. These we all know and love these web frameworks. Well, how about Nix packages? Wait, what? How can Nix packages potentially be a web framework? Well, we're getting to that. So really the question is, what would a persistent Nix evaluator look like? So if we're doing just a Nix instantiate, as in one of the previous slides, that process is very short-lived. It starts up, it evals some code, and it terminates. And there's really no persistence. There's obviously Nix is meant to be stateless. It's meant to obviously run those processes and get the same result every time. Well, what does a persistent evaluator actually look like? Well, because naming a web app framework after a singer is what the cool kids do, like Sinatra, we have Flack. Roberta Flack produced a bunch of music in the 70s. Her pseudonym notably was Rubina Flake. And well, so here's kind of what it looks like. This uses Don's project, HTNL, that renders, well, it's actually currently rendering this presentation. So basically there is this make slide function, and this makes a slide, and then you have a presentation which has a bunch of different slides in it, and then I have the serve presentation function, which basically reaches into the store after building a thing, and well, then we have a bunch of routes. And oh, there we go. There's the routes. And so like we can basically define it kind of like Express, where you have your HTTP verbs and placeholders basically that it matches against the URL. And if you're just going to the root, then it will serve one view of the presentation. If it's /talk/ some path, then it will that's just another view on the presentation. These are pretty standard ways that web app routing happens these days. Well, at least in non-Nix languages, but I guess now Nix. So middlewares and mount points are a thing too. I considered the name Nix-based for this, but ultimately decided on Flack because of the relation to flakes. So you can have use functions. I promise I'm not going to spend a whole bunch of time on this, but like you can use like effectively a middleware that it will run for a component of the path, and then you have your router functions, which you kind of went over. You can inject headers, you can inherit things from the request and echo things out, do any sort of processing that does not require a database. And yeah, I mean it's just pretty kind of Express-like is kind of how it would look, and how it does look. So all right. Let's talk about kind of how we got there. So how do we actually get, start from Nix and get to something persistent that runs in the background that uses Nix? Well, so the answer, at least for Flack, was using Nix-ops Rust bindings. So these are awesome, by the way. It's Nix-ops4/Nix-bindings Rust is the repo. Shout out to Robert Hensing and John Erickson for getting us off Perl for basically third-party language bindings to Nix and onto Rust, because they're, in my opinion, fully usable today, and actually good enough to render the slide deck, with one caveat, and I'll talk about that caveat. But yeah, if you have some ideas that you want to mess with the Nix Rust APIs, they're fully usable. The caveat is multi-threading. So Nix historically has been a very single-threaded system. It's kind of been assumed that there's one user that's running Nix OS rebuild, or one user that's doing a Nix REPL session, or Nix eval or something like that. However, all is not lost. We actually have the bomb GC, which is actually thread safe. So there's a nice API. It's this Nix bindings expert eval state, and you just call that, and it registers the thread on the garbage collector if that thread hasn't been registered. Great. One piece of the puzzle already there. One other piece of the puzzle is that you can clone. I mean, Rust lets you clone things. There's obviously a lot of cloning when you do many things with Rust. Cloning values in Nix is actually kind of special, because in Nix everything's immutable, and so if you clone a value using the Rust APIs, basically what it does is it signals to the GC that it just atomically increases that value's ref count, and there's no actual copying. So you can clone a value using the Rust APIs, and you're just getting a new reference to that same value, because everything is immutable. And that's just how it works. It's just a nice property. So for instance, I've got this function that's in Flack called call function that basically just does some, you pass in a value and it will eval an expression and then call that as a function with that value. And basically I have that value.clone there, and that's not an actual copy, and that's the case for strings, for attribute sets, for lists, for whatever. Yeah, very, very nice property. So there has to be a catch, obviously. We can't just be, say everything's, because everything is immutable, everything's fine. Because at the end of the day, Nix is a tree walking interpreter, and the catch basically is that eval state, which is the actual state that Nix stores for evaluation, in Nix OS/Nix is not thread safe. However, in Nix source, in determinate Nix, it's actually thread safe because of parallel eval. Notably, this manifested during me messing around with this, because the way that most thread pools work for web apps is it basically, the requests come in, they get dispatched to a thread pool, and because multiple threads were simultaneously using the same eval state, obviously that corrupted things and caused crashes and weird results and all sorts of things. So If you want to use eval state and value in multiple threads, basically we have to use a little bit of unsafe in Rust. We have to tell Rust that actually eval state is thread safe by implementing send for it, and also telling Rust that we can send values around too. So for instance, I've got this init state function, which takes a store by the APIs and creates an eval state, and then or deals with the GC guard, and then returns that eval state. And if basically it depends on which variant of Nix you're using. If you're comfortable doing something single-threaded, then obviously you might not need to do this. But if you're doing any sort of persistent application where you have multiple threads hitting the same eval state, you're going to run into trouble unless you do this. So, all right. So we've kind of dealt with the eval. What about the store and the builders? So the store actually is thread safe. It has been for a while. The only thing is, if you're doing weird things like this, you need to basically set the max connections parameter of the store URI to something that's high enough. Otherwise, you'll have multiple clients trying to use the same store, and max connections will just not be high enough. So you'll just get basically head of the line blocking, and everything will be really slow until you realize, oh, I just need to set max connections to something high. And that solves the problem, and it's already kind of nicely thread safe. So that's kind of an overview of the various thread safety limitations in the Nix interpreter. So all right, basically we need determinate Nix to actually be able to do this, is the kind of short answer. Well, all right, we're kind of making our own Nix front end. How do you build a Nix front end? How do you take the Nix source and the Nix bindings and turn the features that you need on? Like, how does this actually work? So basically, you pick which features you need. So we need parallel eval, we need the pipe operator, because some of the frameworks we use, notably HTNL, uses the pipe operator pretty heavily. Flakes, because we can expose, effectively an application in the flake. One caveat is that there's a PR open to fix some issues with the settings API, because set doesn't always work for some internal reasons, basically, but there's a PR open for that. So basically, you just decide kind of which features you want, and then use the settings API in the Nix Rust bindings to turn them on, and once they're on, you can use them. It's pretty simple. All right. So what can we write with this, other than obviously this presentation, which had CGI and JSON and JavaScript going? Well, can we use it to write things that we would ordinarily use the Nix REPL for? Well, so here is search.nixos.org. By the way, you guys can hit this, and please hit it as much as you can. This is actually a public server, VPS, that I'm renting. Search.flack.dev, or for this talk, it's on talk.flack.dev. And yeah, this is actually a full search for some Android env here. Oops, I've got 2 R's there. There we go. It's actually, well, I wouldn't say fully functional, but it's the sorting doesn't work because I just haven't implemented that, and it just gives you I think 100 results by default, but pagination works. And the 2 channels that are on there work too. So yeah, this is actually fully implemented in Nix. I actually had to implement the Elasticsearch API that search.nixos.org used in pure Nix, which was an absolute nightmare. And I mean, in terms of efficiency, it's not awesome because it has to do a linear scan of all the package names. I was thinking, oh, how can I add a trigram index to this? But I mean, it already uses 12 gigs of RAM to do this because it has to index all the packages. So I figured that a trigram index would probably make the RAM problem worse. As far as I know, there's a couple PRs open and some initiatives to at least help with the RAM usage and make that a better problem. But I mean, yeah, actually, so it works with options too. So if I search for I don't know, Steam, yeah, there's all the Steam options. And the metadata actually comes up in them too. So this is all pulling all of the metadata for each of the options, and you can get the metadata for packages too. Yeah, sure, let's do Steam. Oops. There we we go. Let's just pick like this one, sure. So yeah, I mean, it pulls all the maintainers, it pulls all the supported platforms, it pulls whatever teams are maintaining that. Like if I pull, I don't know, let's look at LLVM, sure. Let's see an example of how it parses the teams here. Unless you guys have already brought the server to its knees, which is entirely possible. Let's go back to Android. Maybe there's too many LLVM results or something. Oh, there we go. Oh, there's LLVM. It's just slow or something. Oh, no, we're back on Android. Yeah, there's the teams, and yeah, you can get all the maintainers on that too. So, yeah, any questions? That's pretty much it. Feel free to, again, it's search.flack.dev if you want to see a search.nixos.org API replacement that's just written in pure Nix without Elasticsearch, or for the talk, talk.flack.dev. And then, obviously for the GitHub, numinit/flack. Yeah, any questions? That's pretty much my talk. It was painful. Any questions? Any interesting ideas with the Nix Rust API? Yeah, what's up? Actually, yes. So one of the things that I have not shown is this flakes tab, actually. So it actually loads it basically loads self as a flake. You can actually use input override on this implementation of search to point it at any flake. So right now it's very good question. Right now it's effectively treating Nix packages as a flake. I think, let me see if I did this right on this deployment. Probably not. Yeah, on my local deployment, you can actually, I had an example where it would basically just dump out all the packages and options actually for Flack itself, which it's funny. It just picks its own options up because it just happens to be a flake and it happens to be one of the inputs, so it traverses those and indexes all of them basically. But yeah, you can effectively point it at any flake, and as long as it has, like, I think it's NixOS modules, basically it'll trawl all the NixOS modules, and then for packages it trawls the packages and legacy packages options depending on whether you're searching for flakes or not. Any other questions? All right, yeah, if there's no more, yeah, hopefully you guys have some cool ideas that you guys can use the Rust APIs for. And yeah, they're ready. They're up on GitHub, so do cool stuff with them. Thank you.